My name is Arpit. I'm an engineer here at Databricks. Been at Databricks for a while now, around 4 years. And my co-speaker today is Eric.
Hey everybody, nice to meet you.
Good. Cool. So today we'll be talking about a comprehensive guide to MLOps on Databricks. Now, we're basically going to be going into what MLOps is, basically what an LLMOps and AgentOps can look like in this world of GenAI. MLflow 3.0, the latest basically iteration of MLflow that we've launched specifically built for AI and MLOps at scale. Touch a bit upon MLOps and LLMOps stacks, the prime offering that basically Databricks has to get your MLOps infrastructure started off the bat. And then some Q&A at the end. So I think it's a pretty packed agenda. We'll try to make sure we kind of cover everything. That being said, if anyone has any urgent questions, there's like, oh, Arpit, what you're saying up there is completely wrong, I disagree, please raise your hand. I would love to hear that. I'll try to, if I spot any questions in the crowd, I'll try to answer them. But otherwise, we can, have them all during the Q&A at the end. Cool. So with that, what is MLOps? A lot of you are, I'm sure, familiar with DataOps, DevOps, ModelOps. And the idea is that MLOps kind of combines all of these processes. It's basically bringing, CI/CD and what you kind of do generally for your code to the ML side of things. And I said this last year, and I'll say it this year. I know folks are taking photos, but these slides will be available at the end if you want to save that precious memory, for kids, a picture of kids and whatnot. So, cool. So for MLOps basically, we have this big book of MLOps. And like I said, this slide will be shared later. That link is clickable, but you can also just search it on Google and find it. And this basically book goes into very depth on how to set up your actual MLOps infrastructure. But basically, the set of processes that you really want to kind of think about are, how is my data basically being fed in? How are folks be able to improve their model? That's the DevOps side of it. And then the model's lifecycle itself, how does that get deployed? And all three of these basically combine to make it so that you have a very stable, efficient, and risk basically tolerant system. So this lifecycle, I touched on a little bit, but basically this is kind of your, at a high level, what your lifecycle will generally look like. So you can basically start at any point, but we'll start with generally, where most folks would kind of think about it, which is at the training step. So at the training step, you already have some amount of data, someone has come to you with a business need, or you discovered that, hey, we need to basically build this. You'll use your favorite platform, listed a few there, to basically build your actual model. At that point, basically, the data scientist will also perform some evaluation and see, okay, how is this model actually doing? Is this any good? Is this ready to go? At that point, the ML engineer will take over and say, yeah, okay, cool, it's been validated. That's where the handoff occurs. Data scientist does a bit of validation. ML engineer does a bit of validation. Then we go into deployment. We actually deploy this model, get it out there in production. Folks are using it. People like it. And you're starting to collect the data on how this model is performing again. And that's where we go back into data collection. The data engineer has then set up some pipelines, hopefully using LakeFlow. And then now you get basically that data prep done. You can do a little bit of feature engineering there to clean that up and, again, feed it back into your model. And this cycle will continuously improve your model through various iterations. Now, why should I care about MLOps? So one of the major factors in MLOps is it helps reduce risk. Imagine if today all the engineers in the world suddenly were to lose GitHub and every single version control. It would be a mad dash, right? Like, folks can't even imagine what that would look like. Everyone just committing code willy-nilly, how does that look? So if you think about that, that's kind of the state that we have right now with ML. Data scientists will be like, here's my notebook. Oh, here's my notebook. Which notebook do I use? Which is the latest one? Is this the better one? Is this the better one? Do I have to go run validation every time? It's very, very basically complex. So you want to make sure that this MLOps infrastructure that you set up will help you reduce that risk and basically make sure that you're both compliant and technically you have the right set of models to deploy to production. Now, MLOps will also improve your long-term efficiency through automation. A lot of things that you don't have to do. Maybe you're up at 12 a.m. because you really need to push that next pipeline to the region, in some Asian region, basically, like, oh, Japan went down, I need to stay up. We can do all of that through MLOps because now you can have staggered deployments, automated rollouts, all these things that you normally have on the code side, you can bring to ML. So with that kind of high-level overview, we're going to go into some of these best practices that can help you achieve these goals. Now, one of the best practices that we have is environment isolation. So you'll have your assets, and generally we can divide assets into 3 sections, which is code, your actual training notebook, inference notebook, whatever you have, data, your features, your labels, your actual data that you have, hopefully in Unity Catalog. Actually, probably in Unity Catalog because we'll talk about why that's important. And then your model, your actual model that you build, maybe through sklearn, it's your MLflow model. And the main thing with these assets is, the first thing is they need to be developed. And you want to do this in your dev environment, you want to test it in your staging environment, and then deploy it in prod. And it's important to maintain a good separation here because you want to basically keep the access level in dev open. Everyone should be able to see what everyone else is doing. You should be able to work on everything. But on the flip side, with that comes basically a lower trust in the quality of the models, quality of the data, and quality of the assets in general. On the other hand, with prod, you don't want to touch that. No one should have access to your prod environment except maybe a few administrators and your service principals. So then that makes it so that the trust, quality, and basically testability of your assets is very high. As well as then you're knowing that your customers are getting a safe, basically model, goes through a bunch of checks and balances to make sure it actually gets to production, and it's completely locked down. And there, like I said, there's trade-offs. There's basically pros and cons on each of these, and that's why it's important to make sure you isolate these environments in the right way. Now, another basically best practice we'll go through here is deployment patterns. And commonly, we'll see basically 2 deployment patterns: deploy model and deploy code. Now, the main kind of challenge of MLOps actually resides in this, where if it was just the same as software engineering, why didn't we already do it? Why didn't we just start using GitHub right off the bat? And the tricky bit is that models will basically change each time you iterate on it, right? Each time you basically give it new data, it'll get better, it'll get worse, something will happen. So inherently, models feel like this almost like black box, where you give it data, it changes. And therefore, how can you have reproducibility across different environments? And that's actually what we want to kind of focus in on. So with the deploy model approach, that's kind of the approach that's kind of taken where, okay, I'm going to make it in dev, then I'll do some staging validation, and I'll improve the model using that, and then continue basically doing that in prod. As the prod data comes in, we'll continue to improve the model. Now, this kind of poses a risk, because now, let's say something happens to this model, some weight goes bad or something. How do you roll back? How do you revert? How do you go back to that last iteration that was good? What were the weights? We don't know. And that's why it's important to maintain reproducibility by what we recommend actually doing is the deploy code architecture, where there is basically certain levels of code, and there is, as long as you're using the same data and the same basically hyperparameters and stuff, you can actually achieve a pretty high level of reproducibility in these models. So then you run that code in dev, then you take the code and you actually move it to staging, then you do it with staging data, you validate it. Now maybe, with the staging data, it actually performs worse. That means that the model actually isn't good. Then it doesn't generalize well. So then you do need to go back and go back to dev and try to make a model that works. And so on and so forth. Then the same thing with prod. So deploying basically the training code across these environments will make it so that now if you need to basically revert, it's as simple as rerunning the code and having it go on to another container. So going a bit into this deploy code kind of idea. So in the development environment, you'll train you develop your training code, you'll develop basically the ancillary code, and you promote that code. Once it goes to the staging, you'll test that model training code in the subset of data, you'll test the ancillary code as well, and promote that code. Then finally, you'll train this basically model on production data, you'll test the model, and you'll make sure that it still performs well with the production data, which should ideally be a superset of your training data and what you have in production, and then deploy the model in the ancillary code. And the advantages of doing deploy code will be you have automation, because now you can do automated retraining in lockdown environments. You don't have to worry about basically doing that manually. You have data access control. So only the production environments actually really needs the read access to the production training data. You have reproducible models, engineering control basically over the training environment, and that's going to make it very easy to, like I said, roll back and revert if you need to. And you have support for larger projects. Now you don't have to worry about data scientists changing each other's notebooks, moving that around. Whatever you check into basically your version control, that will be the source of truth. So this next slide is a bit much. I'm sure some folks will take pictures of this one because it looks complicated. But that's kind of the idea, right? Setting up an MLOps infrastructure is difficult. And I'll go through some of the important pieces here. But hopefully the point that we'll show with some of these products is we make it a little easier to set up these basically this environment especially with MLflow 3 and MLOps stacks. But one thing I kind of want to mention is you'll notice at the bottom there, we basically say Unity Catalog. And the nice thing basically that we have with Unity Catalog is you have a complete control over your governance of your data. So what does that mean? So you can see actually in the development environment, there's basically an optional prod catalog data. So some folks will be like, yeah, you know what, my production data, I need to make sure it stays in my production environment. Only my production environment can modify it. But I want to make sure my models are being developed right off the bat with the best data. And that's going to be what we're getting latest from our customers in prod. So it's like, OK, no problem. Just take that catalog, share it to your development workspace, and now you have that data to train with as well. So you can see basically that this architecture can also evolve and adapt based on your needs, but generally kind of conveys some of the best practices that I talked about. I'll pause there for a quick sec to see if anyone has any questions before I move on to the LLMOps side of things. All right, cool. So what changes when we start putting LLMs into the mix? Because now it's completely different, right? You can't do deploy code maybe. It's how are you going to take your LLM model that you spent millions of dollars to fine-tune and deploy code it through the different environments? Or how do you reason about what does it mean to train this model? Well, you'll see actually a lot of it stays the same. The main thing that you're thinking about is the building tuning step, which has now replaced your training step. But you'll still basically need to be able to actually create that lane chain, lane graph, whatever, the actual code that will take care of your model. You'll need to perform some kind of evaluation to make sure it's actually good. Deploy it somewhere, then you'll start collecting data on it. You can feed that back into your model, improve it, and the cycle continues in a similar way. Now, obviously, if it were that simple, LLMOps would be a solved thing and much more of a common industry term, or AgentOps. But it's not. Obviously, there's some pitfalls here. And one of the biggest pitfalls is actually evaluation. So how do you actually have automated, reliable evaluation on something that doesn't have structured input and output? That's the tricky bit, right? So with that, we'll go a bit into especially what MLflow 3 has. But generally, we have a few options there between expert opinions, feedback, random, basically vibe checking, as well as LLM judges and some scorers that you can set up as well. Deployment will be largely the same, except you'll want to set up also some guardrails to make sure that your LLM is not being misused, as well as wanting to make sure that it scales well. But this is pretty similar to what we have in the MLOps world, so I won't go too much into that. Data collection largely stays the same. And then for data prep, you may put your stuff into a vector index. That's the only real difference. And then kind of going back into it for building and tuning. Like I said, it's just your lane chain, you build your tools, whatever else you need to do, but all of that inherently will still be code. Even if you're using GPT-4o, you're still going to need some code to call that. And the model itself may change behind the scenes, especially if you're using a proprietary closed model rather than your own OSS model. But that's kind of, hopefully negligible in terms of what your actual use case is. Because generally, you won't need that model to be able to distinguish, the right dictionary word. You want it to make sure it takes care of your use case and has good understanding of your context, your documents, your data, whatever it is. So with that, we're going to talk a bit about MLflow 3. Before I go into it, any more questions about this is kind of the overview of MLOps section, and we're going to go into how Databricks does this well and better than anyone else? No? OK, great. So what is MLflow 3? MLflow 3, actually, let me get a quick show of hands. How many of you folks here are familiar with MLflow? Lovely. That's what I like to see. So MLflow, you all know and hopefully love. And it has been pretty good in basically the ML world. Built by our CTO himself, Matej. It has worked really well to make it so that you can have reproducibility and have very easy comparisons on what's going on as you train your models. But how do we take that and make it easy to do it in the GenAI world? Because like I said, the GenAI world, you have tools, you have all these other things coming in. How do you take your prompts? And I have different prompts. I want to use them all over again. What's going on in my actual model? Before, you could just say, oh, input, 0 point whatever, output, 1.25. Great. That looks great. Now, is it good? Is it not? So what we're basically introducing with MLflow 3 is a bunch of new kind of, concepts, as well as redefining what we think, especially with that first bullet point, emphasis on the model. So currently in MLflow, the emphasis was on your runs, because you would train your model and then evaluate your model, and it's all about how each run would basically look at it. And we realize, especially in the LLM world, the model is actually much more important these days. It's much more model-centric. So we've kind of put an emphasis on the model and made it very easy to track your model's lifecycle. And we'll be doing some slides as well as a demo, so we'll go more into detail on that later. But that's the main idea is we want to make it so that now it's super easy to understand what is going on with my model. Then the other basically thing that we've done with now having a central model lifecycle is, well, we can also centralize all the performance data and have it be governed by UC. So your metrics, your params, your traces, now all of that is in one location, very easy to see, and you can share that across environments and have all the other benefits of UC, lineage, etc. Tracing, both for traditional ML and GenAI. Let me get another show of hands. How many folks are familiar with MLflow traces? A few less, I figured. So tracing, and I'll go into that a bit into the next slide, tracing is pretty helpful because now we get basically a lot more understanding of what is actually happening behind the scenes in your model. Generally, your sklearn model is a bit of a black box. You just have some weights and it happens. But your LLM, generally, your agent is not. It's going to be calling certain tools. It's going to be doing basically these functions. And tracing makes it so you can see all of that, and you can actually bring it back to traditional ML. For example, your deep learning model may be doing some stuff as well. And you want to actually track when it calls certain functions and does whatever. So you get all of that. We also have something called deployment jobs and activity logs, and basically this is a closer integration with our workflows product and our jobs product to make it such that you have a dedicated deployment lifecycle and a model management lifecycle, as well as auditability on what's going on with my model, what's happened in each deployment state. Assessments and evaluation, so you can now actually go and have those expert feedback, go in, see what's going on with my model. Okay, this is better, is this not good? You can have these experts label it. You can do automatic evaluation. I think we mentioned that. DB SQL support. Now your metrics, your params, your traces, you can take those and actually put them into your AI/BI dashboards. This is really great. Now you can show, look, my loss is decreasing and my accuracy is increasing. So you can basically show all these things now using all the power of DB SQL as well. Prompt registry, which is going to let you basically store, reuse prompts. And as you can tell by my windedness, I'm getting tired of listing all these things. There's a lot. And I would highly recommend everyone to go check out our website, mlflow.org. There's a link at the end, as well as going to the Databricks section on MLflow as well, because managed MLflow is also getting all this and going to be really great. So that's MLflow 3. How does it work with MLOps? How does it improve basically MLOps before we go into the LLM side of things? So for MLOps, we basically make it very easy to go through one of the most standard flows. So let's say for this model lifecycle management, we have your model creation. Data scientist creates the model and performs some comparisons. Now they want to register the model version that they deem best. Today, that's a little difficult. What does that mean? Which model do I register to? This prod catalog, this dev catalog? How does folks know where to get it picked up? A lot of folks have to set up some custom infrastructure using jobs or ADO or whatever to basically say, oh yeah, this is the model you definitely want to deploy to, and this is how it's going to pick it up, and so on and so forth. We make it a lot easier to do that now, basically, with a deployment job. And your deployment job will basically pick up that model, run on the new model version, run that evaluation step, which will create that evaluation run and data. Then the job will pause, waiting for approval. Then the approval will go in, say, hey, looking at all that centralized performance data, this looks great. Let's go ahead and let's move it to production. So something before that was very complicated. So how do I get my actual model version that the data scientist has made all the way to production in a safe and ACL lockdown way is hopefully now a lot easier. So what does that look like? So then the MLflow slide, or in the experiment side, you can basically see that now, like I mentioned, we've put an emphasis on models. So the runs tab you're familiar with. But in these models, you can see that we have these models. You can still see where they're logged from. And we can see as well that, they've been actually moved to the UC, as been seen by the three-level name. So if we were to click on one of these, we could see, here's my model version that was now deployed to UC. And you can see, there's all my metrics, there's my parameters, as well as an activity log, what's been happening. Looks like evaluation succeeded. And you can see with the data set, that evaluation run, yeah, okay, that's basically good. That's my score. Now I can look at that score, I can scroll up and down, decide what I want to do, and say, you know what, yeah, this looks good. I'm going to hit that approve button, and now let's move it along. So, moved it along, it succeeded, and now you can see that it's all tracked in your activity log for good auditability purposes, and generally making this flow very easy and hopefully very simple to use. So, let me give you an example of what a deployment job could look like. These are some templates of, in this case, the top one is what the exact deployment job we used for that model, and the bottom one is one maybe you can set up. The nice thing about deployment jobs is they're flexible. Folks will have all kinds of different things. Some people will like the top one where it's like, yeah, do an eval, let me just approve it real quick, and then I want you to deploy to my model starting endpoint. Some folks will be like, no, I want granular rollout. I want you to roll it out a bit, maybe 1%, and then I want to do more checks, and then 10%, and then more checks, and then I want to get legal involved, and then more checks, and then I want to make sure there's a bias and fairness check. Sure, whatever you want, you know? And that's kind of the beauty of it. All of that will then be visible in your activity log. You can see what's going on, who approved it, when they approved it, all these information will be there. So great auditability, as well as being able to see in a very clean way your deployment state on the actual model itself. So you can quickly look at all your model versions, be like, this one's deployed, this one's not, I see what's going on here, as well as what's going on with each version. So for the the traditional ML side of things, MLflow 3 has made it very easy with centralized performance data, as well as everything else, the deployment jobs and activity log, to now have a complete MLOps lifecycle right off the bat. That's a pretty simple case. What if I want to do something more? Well, the idea is it's customizable. So let's say now you basically want to do deep learning. Well, we've pulled out the concept of a deep learning checkpoint into its own model. Before, you'd just have a training run. You'd be like, I think it was version number, checkpoint number 12 I like. Let me register that to UC. Oh, where to go? I have to go to UC. What's going on? We've pulled that all out into dedicated models. So now when you're doing deep learning as well, you see, OK, this is my favorite model. I can see all the metrics. Here's my charts, comparison across everything. As well as now, I can set up custom tracing. I can say, I want to basically know when this model passes this certain checkpoint, or when it basically calls this function, I want to log this trace. And going back to this, the simple example, it wasn't exactly code deploy. It's just taking the model and maybe in a single workspace, deploying through all the regions. For a lot of folks getting started with MLOps, it's the easiest way to get started. We want to make sure that even folks who are like, I just spin up a workspace, my data scientist created a model, well, you can get governance and lockdown right off the bat. So you can even do it without having to worry about setting up a full deploy code architecture and be like, yeah, I'm just playing around with this. Great, you can still have reliable governance, ACLs, and approvals. But for the code deploy approach, how would this work? Well, you can set up a deployment job in each environment. You can basically say, OK, now once my data scientist has basically registered this model to this one, it'll kick off this job. That job can basically go and then now run the next one in staging. You can set all that up, and you'll get basically activity logs across all of it. The nice thing about deployment job is you can then use the same model or different models in different environments. Use the same model. Each deployment job is workspace tied. So then you can have different basically activity logs showing up from all of your your production, staging, and dev environments, basically on the workspaces that you want to. So you can see what's going on, or you can isolate them. And something that we have that's coming soon is actually job triggers. So deployment job makes it so that you can basically have one centralized job that manages the lifecycle of your model. But a lot of times, folks will have different jobs for different things. Oh, well, as soon as someone registers to basically this staging catalog, I want to immediately trigger like a bias and fairness check. Sure, with job triggers, that's doable. What we'll basically make it so that each time certain events occur, you set an alias, you set a certain tag, you set basically create a new model or model version in specified schemas and catalogs, it can auto-trigger a job. Now you can see how this basically makes it very easy to set up your entire infrastructure in-house without having to go and say, oh, let me go set up ADO, let me go set up GitHub, let me go transfer my tokens over. Hopefully this makes it a lot easier. The other thing that basically we'll talk about with MLOps stacks, and we'll come back to it, is you can also integrate this with MLOps stacks as well. So it actually is not a replacement necessarily. It can be on the earlier stages, but it has a synergy with it. Once you have a more advanced architecture, you can have a bunch more deployment jobs running for each project. So that makes it hopefully a lot easier to manage, like I said, the entire infrastructure within Databricks. Last thing I want to mention is the AI BI dashboards with DB-SQL. So like I said, the metrics on performance data and all that stuff is going to be in DB-SQL. So you can set up these AI BI dashboards very easily and see exactly what's going on with all your models across all the different environments. All right, before I move on to the GenAI side, any more questions? I know I'm pausing really less because I'm hoping there's no questions so I can keep going, but if there are, no? Okay, great. Oh,
Come on.
I'm kidding. Go ahead. We're getting a mic over to you. And I'll repeat the question too so that for the recording or folks watching online, they can hear it too.
I'm a little bit confused about the direction we're headed to. So is the idea I don't need GitHub workflows anymore or my Bitbucket workflows? I'll be managing everything from the Databricks environment with MLflow. Is that like the target state?
So yeah, that can be a target state. We know that folks already have set up their workflows and everything in Bitbucket and everything. So we don't want to necessarily say that they can't use these with as well. Because generally, even if you set up something in Bitbucket and stuff, you'll probably still have a Databricks job at the end that needs to run. Now, instead of having that Databricks job and go call some MLflow commands and do everything, you can just basically say, I just need to, the only reason I have this Bitbucket flow is so that when my data scientist checks in a PR, it just automatically trains that model. Well, you can just do that now with the deployment job, right? So the idea is not that necessarily replaces it, but for folks who are getting started, who haven't actually set up the Bitbucket and GitHub workflows, yes, I imagine actually for them, hopefully this should actually replace much of that functionality. They can now just set up everything in-house. At some point, if you decide, yeah, I want to migrate things over, you can definitely do that. Then we also have Databricks repo integration. So if you still want to keep your stuff in Bitbucket, GitHub, whatever it is, you can. Or you can use a different version control because now you're not necessarily locked into that one. That answer your question? Great. Cool. Okay, sorry, one more question.
Similarly to her question, I was curious if how this integrates with Databricks asset bundles and like those sort of workflow deployments.
Yeah, exactly. Great question. So you can set up your deployment job via a Databricks asset bundle as well. So let's say you have your entire MLOps infrastructure set up via MLOps stacks. MLOps stacks use the Databricks asset bundles, and I'm sure maybe you have your own custom way, but I'll use stacks as an example because what we do is we declare an experiment in code, we declare a registered model in code, we declare some jobs in code, and then we kind of say, now all that is deployed, but you don't have your model versions yet. You don't have any of that stuff because you deployed your infrastructure. You haven't actually done all the training yet. The infrastructure as code is separated from your actual dynamic, basically training workflows. And that works perfectly with deployment jobs because then you can still declare, these are my notebooks, this is exactly how I wanted to train, evaluate, and do everything. Just have that all in code, deploy it, have the deployment job ready to go, so as soon as you even train your first model version, it'll immediately trigger and fire off that deployment job. Answer your question? Cool. Now, going into a bit into GenAI and LLMOps with MLflow 3.0. So this is now basically the GenAI experiment, and you'll notice it actually looks a little bit different than what we just saw for our MLflow traditional experiment. There's traces, evaluations, labeling, et cetera, and you can see now basically the first tab is traces, and we're really focusing on tracing. So I'll come back to that in a sec, but let's go into first the first step of that cycle that we talked about, which was the LLM building and tuning. So here's some popular, basically, platforms to get LLMs or build your own LLMs on, or building basically wrappers around LLMs. And you'll basically have it in your code. You'll create some basically notebook, and generally have this ready to go. Now, one thing basically that you'll see then is with tracing, what can we do? So if we basically look into this trace, we can click into what happened with this input MLflow. So you can click in and see, okay, this is the input, this is what the system prompt was, this is the user, these are the components that are basically used, key components, as well as you can see what's going on with, okay, this was the completions, now, what basically happened there. And I'll go in, there's another basically example later on that's a bit more complicated when you have a bunch of tools. Which tool was actually called? A lot of times, for example, you realize that your LLM isn't working as expected simply because the keywords that you provided wasn't using the right tool. Tracing makes it very easy to see that. How long did it spend on something? Maybe you accidentally put a time.sleep for 10,000 seconds. I don't know why you would do that, but if you did, you'd be able to see that in your trace now because now you can see in that function that took a really long time to basically run. and so on and so forth. Tracing makes it very, very basically easy and powerful, so that basically when we go back to this, you can see all these traces, you can know exactly what's going on in your model. You can see what's being inputted, where it's basically spending time, as well as when we go into basically evals, you can label these traces and then feed them back into your model as data. So, going a bit into evaluations. So this is an example basically of your evaluation. So we have basically certain labels here that we've added, pass. You can click into it, you can see that trace basically. You can see, these are the assessments that your experts added. Here were the inputs and here were the outputs. And you can kind of basically see very easily and compare, especially if you were to then go into the chart view, what's going on. How are traces basically behaving? Now that's kind of interesting because generally when you would think about each of these requests, they could be very different requests. Someone might say, what is MLflow? Someone might say, my dog's tummy is rumbling. I don't know why they'd use your chat app for that, but they might. Now you can see then basically with all these different kinds of inputs, how can we generalize? How can we have charts? And that's the idea, especially with assessments, you can basically set up your own custom scores, as well as use basically our built-in and generally recommended scores to see how the model is generally performing on a wide variety of inputs and outputs. Speaking of scores and monitoring, so on the left we have a code snippet example of basically what it could look like to set up your own evaluation with a custom score. So we have this new endpoint MLflow GenAI evaluate that makes it very easy to then add certain guidelines as well as putting in your eval data set. And you can see, and on the right there, basically, this is what it would look like as you basically add certain assessments and basically you set up your monitoring, so that now, not only you can go and compare when you're actually building and tuning your model and improving it, you can also even see when it's in production when your model starts to degrade and why maybe it has degraded, especially with the latest versions. Again, something that we have in MLOps side, but now we can also have in the LLMOps side. So this makes it very easy to understand and know when something goes wrong and get alerted on your model. And the interesting thing about the main kind of difference between GenAI and MLOps development is a lot of times basically you'll need to iterate on your model as basically you're deploying it, as it's in production. Whereas oftentimes you can do clear boundaries in ML, like, yeah, that one was deployed, sucks, let's go on and basically say the next version will be better. With this, basically, you can say now, okay, I actually want to collect these traces. Yeah, these traces, now I'm going to use that and feed that back into the same version of the model and improve it, and then it's kind of an iterative loop. So that is obviously an option. We also, I'll talk about this in a sec, but we also have versioning, and I'll kind of go into that so you can actually have dedicated versions of your LLM as well. But before I get ahead of myself, this kind of shows the automatic evaluation side of things. This shows how you can set up that auto eval with scores, and you can see that, okay, now with my deployment job, this can actually run automatically, and tying back into how we were using MLflow evaluate on the traditional ML side of things, this will make it so that you don't actually have to worry about manually necessarily doing that first pass on your LLM to see if it's actually performing. But generally, after this, these scores and this, setting this up, you'll be like, okay, well, I want to actually see, if my experts agree that this model is good. And we have two ways to basically make it very easy to have expert feedback. One, we have basically this review app. And this review app, you can basically go in. When you ask it certain questions, you can say, provide your feedback. Performed well, didn't perform well. This will get logged as a trace, as well as basically everything that you provided feedback on will also get added as assessments. You can also create a dedicated labeling session and send that over. And this labeling session, you can go in and actually take existing traces and say, yeah, I want to go and label these are good, these are bad, so on and so forth. And it makes it very easy for your experts to provide their feedback, and then you can use that to improve your model. So we talked about the building side, we talked about the evaluation side. The next side is deployment. So like I said, you can still use your deployment job. Maybe we're keeping it simple with just the evaluation approval. Obviously make it as complex as you want. And then after that, for the deploying step, that's when we integrate into AI Gateway. Now, AI Gateway is very powerful for folks, I'm sure, hopefully you've done any kind of model serving. It provides a bunch of basically things. These are just a subset, with the usage tracking, payload logging, guardrails, A/B testing, granular limiting, and that comes on all of your LLM deployments. So if you're using an external model, sure, yeah, you get it on OpenAI. If you're using the Databricks hosted model, yeah, you can get it on Meta. And if you want to use an agent and chain, you can get it on that as well. So all of these will then basically have this dedicated deployment capabilities, and you can just have that as a single step in basically your Databricks notebook. Something as simple as agents.deploy, and then when you're like, I don't want to use this model anymore, no problem, just switch it out. And it makes it very easy to create that same deployment job template for maybe several different cases. Because now all you just need to do is switch out the model. Everything else stays standardized. But kind of getting a bit further into Mosaic AI Gateway, especially the payload logging inference tables bit. These inference tables are great because now, we talked about this with like traces. Now, not only were you basically those offline traces that you had during your batch and eval, now you can basically do it during online as well. You'll be collecting basically all of your logs in real time, and you can get all these traces as well. So you can see, basically on the top example, that, oh, someone queried it. What happened? You go into the inference table. Now you can actually see that trace pop up. And that makes it very powerful because now it goes and feeds back into that whole loop again. Now you don't have to worry about, oh, I need to go and get all this basically production data. Hopefully my eval data was good, but I don't know how it's going to go. And then when you're collecting production data, make sure that, oh, maybe I need to trace it somehow. Maybe I need to log it. It's all taken care of. And then you can take those traces. You can go in and basically set up labeling sessions, have your experts basically go in and then say, yeah, these assessments are good. These assessments are not. And then if someone were to basically say, hey, what is MLflow? You can even add a new assessment like actually useful data. And going back to the guy who has that dog with the stomach issue, you can be like, yeah, I don't really care about this response. Don't ignore it. So you can make it very easy to see what's going on there, as well as have generalized statistics. At the bottom, you can see basically this inference table. It's governed in UC. It's a UC table. Now you can share it. You can show it. You can send it across to maybe like there's a regulatory org. You send it there. They'll do some checks. Maybe you have an AI/BI workspace. You can share the table there. They can set up their own AI/BI dashboards on this data and say, yeah, I want to see how these traces are generally doing. What kind of questions are we getting? All that is now very easy and doable. And I'd say I'd cycle back to this with versioning. So we do basically have model agent versions as well. So like I said, you can improve the agent with the traces, or if you want to do a clean cut and say, no, I want to change how my LangChain looks, I want to change which tools I'm using, you can set up different basically versions as well. And we make that very easy, like I said, by pulling out the model and agent concept into these dedicated versions. You can share these versions, and then you can treat them as how you would with model versions. And that makes it a very, very clean and easy way to reason about agents, rather than being, oh, did this improve? Which tools is using? Oh, did someone improve this agent? You can just cut them off and have basically dedicated versioning similar to everything else. On the other hand, we have something that we're actually launching in beta called prompt registry. We actually already have this on the OSS side, and we're introducing a managed version that will be governed in UC. And the advantage basically to your prompt versions now can be, yeah, you had basically certain prompts, and you want to iterate and improve them over time. But you can go back and see when I trained basically this model, or fine-tuned it rather, which prompt was it using? And you can see how it performed with assessments and evals and traces and be like, oh, this prompt was performing this way, and it's all connected easily through lineage. Whereas now you can see this new prompt. Oh, yeah, it's performing much better. These are the kind of feedback that we should be getting, and this is how we should be structuring to get the right response out of it. Prompt versions and prompt registry makes it very easy to basically do like fine shot and few shot tuning on your actual model, as well as improving it. Okay, I think I just yapped for 40 minutes there. I know I took a couple questions, but I want to make sure I pause for a second if there are any more questions before we go into the demo. No? Is this stuff? Oh, we have one question.
I want to double click on the prompt development process where domain experts and the person who is kind of developing the prompt, how easy or difficult?
Sorry, could you bring the mic a little closer?
Yeah. Mm-hmm. So I want to double click on the prompt development process where domain experts and the person who is actually writing the prompt, how easy or difficult will it be using the view which you were showing previously to collaborate between these two?
This one, right?
And the screen previous, like where you were showing developing the prompt,
This is about
like getting the feedback.
This one?
Exactly, over here.
Okay. Yeah, so the idea is that we've kind of integrated it into all these things to make it very easy to develop your prompt. The idea is that you can set up templates with these, basically the prompt registry. So you can have, maybe, let's say you have a guardrail, like a simple guardrail, a system prompt. And you want to make sure that everyone in your org is using that system prompt. What you can then do is you can say, in basically this catalog and this schema, you set up basically template prompt. Everyone else will then basically start from template prompt, use that, and then basically inherit that, or if you want to, or you can then extend it, copy it, and then set up your additional prompt information beyond that. So the idea is that, yes, everything you're saying, it should be very easy to do. You should be able to see other folks' prompts. You should be able to use these template prompts to get started with writing your own, and then you should be able to evaluate these prompts as well, and then see if you need to improve them or make them more like clarified. Make sense? One more question up front?
Andy?
Okay, I'll just repeat the question. Go ahead.
Some of us are interested in, creating multiple networks. How is that stuff going to get integrated into this particular product? Because some of us want to use it not as a one-off thing for someone answering a question, but as a corporate thing where you can have a sanctioned place to go and do operations that result in multi-agent stuff. How will that get integrated? Is there a plan? And
yeah, I mean, the beauty of this is that this works with your single agent, multi-agent, all these tools, right? So let's say we set up, Databricks has MCP support. So let's say you set up basically your MCP tools and you have your catalog that you set up your server. Now you basically have certain connectors to, let's say, other organizations. You have a federated architecture. You have multi-agents. You have agents in other orgs and like other, basically connectors. Maybe you have a Salesforce agent, so on and so forth. How can I use all this and get all these functionality, right? And the idea is that basically all this will still work as long as basically your top-level agent is still within Databricks and basically using MLflow. Because you'll still get the tracing functionality of it. As long as it's there, you'll get the evaluations. Experts can go in and feedback. Except now, what the beauty of tracing is, instead of just seeing a tool, you can see, oh, Salesforce agent, you gave it this response, and it gave it back. And you're like, wait, that's wrong. Why is my Salesforce agent behaving this way? And then you can go and basically debug in there and figure out that was the issue rather than your entire agent architecture. So all this works with multi-agent just as well as it does with single agent. One question in the corner there. And this will probably be the last question before we go into the demo. I want to make sure that Eric has enough time.
Hi, my question is on the version. So in the prompts as well as in the model, you showed that there is versioning. How do, let's say I came to version 7, but now I feel that my version 2 was better than version 7. So how do I revert back to version 2? Is it an easy process?
Yeah, that's the beauty, especially if you were using a deployment job, is now. It's as simple as now. You just take basically version 2 and rerun that. So if you saw on, I don't want to click like 40 screens back because this clicker's a little slow, but basically you saw that there was a redeploy option on every single basically deployment job after you deploy it. So what you can always just do is go back to version 2, you just click on it. Like in here, you can just click on it and you see, and you're like, yeah, I just want this, hit redeploy, and that's it. Because you set up your code in such a modular and easy way that it's easy to roll out new versions as well as revert. Okay, now we're going to go into Eric's basically presentation. But before I do that, how do folks generally feel about the content shared so far? Excited? Oh, there we go. You get a round of applause to start you off.
Right on. Well, here, let's see. Let's advance this to 1. Cool. All right, so I'm going to switch over. Hey, everybody. My name is Eric. It's nice to be here with y'all. Thanks for attending the session. I'm going to go through a couple demos. And did you already saw Twitter? Okay, fantastic. So we just heard Arpit's talk. He gave us some great tools and great suggestions on ways to do best practice for MLOps that we can extend to LLMOps and to AgentOps. And so I want to provide a couple demos. The first one is going to be an example of me doing the best that I can to adopt those principles that he just provided of having separate environments, setting up CI/CD, doing deploy code, all those amazing things. but we're going to look at it through the lens of traces and evaluations because I want to show what happens in production or in real life when we actually catch mistakes. How quick can we go from catching that mistake to rectifying it in real time? So let me first start out by showing my environment. So I have 3 separate catalogs that are representing our different environments for dev, stage, and prod. In dev, our data science team is doing their kind of work, their day-to-day instrumentation, trying different things out, kicking the rocks around and everything like that. So we can see that the schema is set up in the same way for all these. And specifically in the GenAI schema, I have a model that I deployed into production. Oops, into prod. Yeah. So here's my MLflow DACE 2025 application. I really want to show it to you guys, so let me go to the playground and rip out a couple prompts and let's see what happens. And so the model or the agent that's deployed is like a very simple canonical example of just an LLM with a system prompt and deployed as an agent. So let's show what this looks like. Okay. So here we go. I'm in the playground. I want to go ahead and use this. And let's just ask some general questions about MLflow. So what flavors are supported in MLflow? Let's see what we get back. Okay, so I didn't add streaming in this. Uh-oh. So when we read this back, you be wanting to know the flavors of MLflow. It looks like I got hijacked by a pirate. What am I going to do? So now when I see this is something that's being exposed to our customers because this is in prod. So when they're asking questions at my endpoint, they're getting back this like wacky pirate response. This is an issue, right? So what I want to do is kind of start to use these tools that are part of MLflow 3 now that allow us to see tracing and evaluation. The quickest way that I can do this and diagnose maybe what has happened is I go back to the catalog and I go back to the model view of this prod model. I want to find out first and foremost, was this always deployed like with this pirate voice, or was this ever deployed actually normally? So I can look back at the original version and I go ahead and study the trace of the deployment and I can see back. So you'll notice like a couple different things. I'll just pull your attention to the tags column. At the very bottom here, you'll see that these are actually traces that were gathered from my evaluation when the code was actually deployed. And these request IDs are actually being pulled from the inference table from the endpoint itself, so we can view these kind of as they're coming in, if you will. So I'll go ahead and look at the detailed view of this, and I can see, hey, someone just asked what the MLflow flavors are, and originally they got a response that looks normal. So somewhere along the lines, something happened where someone, one of maybe my colleagues, maybe it was even me probably, who had made some mistake and deployed this into production, right? So let's even go back in time like one step further. And again, this is the power of having isolation of environments. I want to look back in my experiments. And I know that because I'm doing CI/CD and deploying code, that each time that my code is landing in an environment, I'm running a workflow, it's executing, it's registering a model, it's doing evaluation, it's doing all this stuff that's going to give me telemetry about what I'm doing. So I can look back at my staging experiment, and I can see that I have some evaluations that I had set up for this. Specifically, I was looking at the safety of the responses that are coming back, and also the correctness, which is shown in the evaluation. And I'll show that piece of where that came from. But again, this is in the staging environment. So I want to see, I look back at the trace here, and I get back the same kind of thing. I wanted to know about MLflow tracking, and I got back like a wacky pirate response, right? So again, knowing kind of the nature of how we move things from dev to staging to prod, I know that for every single time that I'm getting one of these traces or one of these deployments or the endpoint or anything like that, I have like a workflow that's kind of like tethered to it that I can go back and reference also. So I'm going to go back to our workflows, and I'll look at what happened in dev, my deployment. So originally, the first couple times you can see that these are, if like me, I have to fiddle around and I have to see what works out for me, and then I can finally deploy something successfully, right? So I'm going to go to the code really quick and take a look and see, because let me go back and show you where this is coming from, right? So I have a repo that I created, that has my CI/CD code, my GitHub workflows. Let me just give a little context. So what this is doing is this is just defining for each step along the way, every time that I'm trying to merge code to one of the environments via the branches, this is going to do deployment for me. Then as far as my DAB is defined, I have two key components to it. I have the Databricks YAML, which defines the actual workspaces and maybe like any variables that I'm adding or pushing down to workflows and things like that. I have that file defined. And I also have the resources in my deploy. So this is the actual definition of my jobs that are being, or my notebooks that I'm really putting into production. So there's really only two places that this can happen, right? Because I only have two notebooks. I have this example that I'm trying to share, and then I have this deploy. So let's go back to the workflow for a minute, and I look in the dev. So I could look back in each of these tasks and see which notebook this might have been caused from. Let's look in the deploy first, going backwards, right? So I'm just loading in some libraries. I have my widget that's grabbing which environment that I'm using. And I'm doing an agent deployment. Really pretty straightforward stuff, nothing that's going to infiltrate to make it look like a pirate, right? So it's probably coming from the place where I'm registering the model itself. So let's go back there. So now I'm going to the register model task, and I can look at the notebook where this was executed. And again, this is just a simple like LangGraph wrapper pretty much for an LLM with a system prompt. So I'm looking here, you know, we're looking at this, where this happened, what's happening here, what's going on. Here I am, uh-oh. Here's the problem. Someone put in my system prompt, again, it could have been me, that we want our responses to be that of a nasty pirate. So that's how we're starting to get these responses back that got pushed all the way from dev to stage to prod, and we're able to see it through the trace and the evaluation and ultimately the workflow itself. So we got to go ahead and change this, right? So I'm going to go ahead into my notebook here. I'll create a branch. It's my MLflow pirate. And then we'll make this quick change, and then we'll show the CD. Okay, so let's make this change. You definitely don't want to be the pirate anymore. Okay, so I'm going to go ahead and commit this change. No more pirate. And then I'm going to go to GitHub and I'll open a pull request for this. So let's go here, and we can see that this updated my MLflow pirate. So now I'm going to start the process of kind of going from environment to environment to environment, and this is going to start with taking my feature and putting it into dev. I'll open the request. I'll ask RPit if he'll approve my pull request. Good to go. We got the stamp. We're going to merge this in, and then this is going to kick off my action. It should kick off my action. There we go. Okay. So basically, this is going to give us the tools. So from what I showed in the demo, just a quick recap of it is we saw that there was an issue in my production endpoint. We're able to follow through traces and evaluation from each environment, specifically where this is rooted from. I committed a change onto the dev branch and then started to push the code from left to right along the line to get the pirate, the pirate out of our nice waters. I have another demo that we prepared too, so let me go ahead and skip to that really quick. And before I go to the next demo, is there any questions on that specifically? Yeah.
My question is regarding when you were showing before, when you saw the pirate language, and when you went to the evaluation, it said correctness wrong. But that's very subjective. I mean, what if I want that? So at this point, your judges are broken because this is what I wanted. I mean, what if I wanted a pirate site? But I was wondering about your scoring too. So this is where I have a question mark.
No, that's a great question. So I kind of glossed over that, so thank you. So let me show you what this would look like, potentially. So this is where the idea of assessments comes in. So if I go back to that rightness or wrongness, right? You can see on the right hand, it has the correctness, the safety, and then in my evaluation that I would have defined, I would have had like a set of expected facts that we thought, subjectively, were the correct ones. But what we can also do, if you're an expert in the field, you could go ahead and add your own assessment to this, where you can add your feedback, pirates are awesome, or whatever the case would be, right? And you'd be able to add that assessment, be part of your trace. I couldn't hear you, sorry.
Yes, but doesn't explain why correctness is a no, because I'm a little bit, you don't have any other
I'm
additional
sorry.
constraint. Yeah.
So that definition, I'll show you where this is coming from, and thank you for bringing this up. So let's have a look. So if I look back in my notebook where where this is coming from, all the way through this here, I have a little piece in some of our pitch slides where there was pieces defined here about this, but evaluation, right? So part of this evaluation is I define, maybe as an expert, what the evaluation should be. So if there's a specific manner in which like a question should be answered, or there's guardrails, maybe there's something that the company it has to have a specific type of language or guideline, if you will, you can enforce that in your eval. So that way when it's passed to the GenAI evaluate, you invoke that score. And you could create custom scores as well. So you'd be able to kind of enforce to make sure that your expert opinion is aligned with those types of judges. Yeah.
So my question is related to that system prompt you had. Some of this previous stuff that they were showing before this was how the system prompts are supposed to be able to be logged directly in MLflow. You're supposed to be able to track them. But what you're showing here is you actually had to go into the notebook to find that the system prompt was changed. So is that something else that you're supposed to be tracking that somewhere else to track that system prompt?
Yeah, I mean, I wouldn't take this as certainly like, this is more for illustration more than anything. But the way that I've seen prompt management is probably the way that our pitch suggested, and the way that we have the prompt registry is going to be the better way to do it. That's in beta right now. But I've seen like in examples that I've done to either have like a config file that has the prompt itself, so it's separate, kind of decoupled from the actual execution code, so you can manage it in its own lifecycle. Yeah, Andy? Maybe we'll do one more, and then we'll save some time for Q&A at the end.
Yeah, my question is basically, when you found the issue and you saw that it used to work properly before, maybe from the engineering side, or maybe like probably the common workflow will be that, hey, recover first and then fix the issue. So most likely you want to redeploy an older version. I'm not sure if you're going to show that, or the same side on the Git, you probably do every part instead of like trying to fix it.
You're saying instead of fixing the problem and then redeploying, to just redeploy it? I'm not clear on the question. I'm sorry.
No, you saw that this is a regression happened, right? It used to work and now it is not working properly. Then most likely the most likely workflow is that, hey, use the last known good version.
So instead of fixing, just redeploy the version that worked before. Yeah, that would be an option too, right? I mean, kind of like what our pitch just, his example before. If this was a deployment job, which it definitely could have been, you just redeploy the version 1.
Okay.
Let me just continue, and we'll do some more Q&A at the end, if that's okay. Do you have the clicker? Do I have the clicker? Let me switch first. Yeah. Thanks. Okay. So for the next kind of demo that we want to do really quick is talk about MLOps stacks. So MLOps stacks is an infrastructure that's provided It's customizable, that it helps us to manage the lifecycle within Databricks and follows the best practices here. So we're able to create production MLOps infrastructure on Databricks by following like a fantastic template. So this integrates fairly readily with common providers that are doing CI/CD, like GitHub and Azure DevOps. And this helps us to manage assets as infrastructure as code through Databricks asset bundles. So this allows you really to focus from a data science perspective, to really focus on doing ML, the nature of your job, and really helps to get started with project development by using the templates that are available. And for those who are MLEs, this really helps to just identify how to set up, where to set things up properly to make that life cycle a lot smoother. So then once that template and CI/CD is set up, then there's a solid template of being able to walk through and makes the life cycle of development a lot faster. So let me advance here. I'm going to keep this pause for just one moment. So I'm going to show a demo, but you're able to follow this on your phone or on your web browser, if you will. So I'll keep this up for just a minute. All right, I'm gonna switch over. Okay, great. So we should be here. If you're following the link, then you should be at a site that looks like this. So we'll go ahead and explore this. I'm gonna just talk through this, but please take the time as you would need to click through this on your own. But basically, this is a pre-set up version of what the MLOps stacks deployed version looks like. If you were to set this up from scratch, there's like a couple items within like the CLI that you would add, like what's the name of your project, where's the host of your Databricks workspace, what do you want to call the project, what's your provider. There's really about like, I'd say like maybe 5, 6, 7 pieces of prompting that needs to be done to fill it out, and then this pretty much just creates this full-bodied repo for you. So the README that's in here covers like how to do this and the different components of what you'll need. So let's go to the next part. So here, this should look like a familiar illustration that Arpit shared in his graphic before, but this is really about like enabling like data science teams to really work in a more streamlined fashion and not have to get hung up with some of the things that sometimes can frustrate us. So by streamlining the template for CI/CD and the way that code can be deployed through different environments just streamlines a lot of work. So the graphic here just is showing that, a reiteration of what we saw earlier. Okay. So to start the new project, it's showing us here that you really are just doing like an init of a cookie cutter template, and then filling out some of these attributes that I had mentioned before of what's the project you want to call, is this a CI/CD only, what's the root of the directory. There's just a couple pieces that we need to fill out really to get us started, but it's pretty simple stuff. Okay, so after filling out the templated piece of what you need, this now is actually a deployed version of MLOps stacks, what it looks like in an actual workspace or a GitHub repo. Okay. So let's take a look here just of the structure of MLOps stacks, like what do we get? So the nice thing about this is once we're filling out like the template, we get like all these things that are pre-populated for us, and we get a lot of information up front to like help us walk through how to walk through this as if you're a data scientist, if you are an MLE, like what tasks you need to do, where you need to complete the tasks, specifically what you can do, the help pages that you need to find. Everything is kind of like contained like in a nice delivery for us. So you can see the code structure here we followed our ML code, we have the resources, and then CI/CD. So we have the structure of this is spelled out here for us. So like we had mentioned, this is part of an extension of using a DAB. So you'll see some of the similar kind of like terminology that if you've used DABs, you'll see it in MLOps stacks. So you'll see that there's the Databricks YAML, and there's also the resources that have the specific things that we're using to deploy. So in this specific case, we might have some requirements of our modules. We have the Databricks YAML, which is that definition of where the assets need to be deployed, the different workspaces. We have a folder for training, validation, monitoring, and deployment, which is going to contain like the individual pieces of code that do those specific tasks. And then within the tests, if we're doing like unit tests or integration tests, those would be placed there. And then there's resources for the specific, tied really to the specific task of what we're doing. Oops, I lost my button. Okay. So yeah, please take a minute to read these on your own, but I'm just going to kind of like zip through just for the purpose of time for us. So like I had mentioned, for each of these specific components, there's a kind of a step through of how to set this up. So if you're a data scientist, it walks through like how you would commit code, open a pull request, and then move that along the process. If you are MLE or MLOps person, you might be the person who's responsible to find service principals, create secrets and things like that. It tells you, gives you instructions exactly how to do that, which is fantastic. Right, so here there's going to be a little bit of like assumption that we've assumed that we've already completed some type of work up to the next piece. So let's kind of move it on and see what actually starts to happen once we start to work with this. So let's suppose here that I switch to the dev branch, I write some code. The pipelines themselves have been updated. We go ahead and we click on the project name to find the training code itself. Now, in the training code, delightfully named train, we're able to go ahead and make the edits that we want to our specific code base that we want to execute. So suppose in our specific example, we're training a light GBM model, and maybe I want to change some hyperparameters, and I want to change regularization or something like that. I go ahead and I would go ahead and I'd make my change, right? So we can see that this is registered in Unity catalog, and it's using the light GBM flavor. And then finally, once that experiment is executed, we're able to see all the information back in the experiment view of this. We get the metrics that are meaningful and that we care about, and we get the summary of all the metrics that are logged in the model run itself. So one of the things that we want to call out here is like if we look at the R squared, because this is a regression problem for our light GBM, we look at the R squared score. This turns out to be like almost 0.93, which is fantastic. So we decide that we actually want to move forward with this code. So then once we go ahead, we might provide an alias for this to let us know that this is in fact the model version that we want to promote and we want to use, or the code. And they'll go ahead and create a pull request for it. Okay, so we create the pull request. And then finally, this is going to start to trigger my integration testing from the CI/CD. Yeah. Okay, so this is going to trigger the CI here. And this will do, within the CI, it's going to validate the bundle and then finally deploy it for us. Okay, so we can see this. And if there's tests that are being run, I'd be able to include that in the CD script itself. Let's view some of the tests. So now we can see what's happening in the inference as this is running. So the inference test is running for us. And we can just check out to see what's actually happening, and this is running right now.
Finish it. We'll be good. Reserve more, right? Yeah, just keep it. Scroll up. There should be more. Click on it. Click on the actual, yeah. Click on that link. Click on the run URL. That run URL. Click on the run URL.
Oh, so now, thank you. So now this is run, and we're able to see that this actually kicked off that job. So it's doing the training, it's doing the model validation, and the deployment itself. All right, so we're not going to go through necessarily each of these, but we're able to see that the action kicked this job off for us once we merged. Okay, so our test run for inference has been completed also. And let's take a look here. We can see what this looks like. We can merge it. All right. So now we're merged to main. We're in prod. Okay. Let's take a look and see what's happening in here. Okay, so we can see the individual actions that are being carried out on our behalf. And you notice in this case differed from, this is using service principals here. And we're validating within the YAML the file for staging. And we'll go ahead and deploy that to staging now. Okay, so we'll navigate to the jobs. We can look for our job, and we'll get to see our jobs that are showing up. Okay, so now we go ahead and want to release. Okay. Okay, so now we have our release branch that we're going to merge to. Okay.
Let's stop there.
Yeah, okay. All right. So we are going to move to the next piece. Got it?
Yeah. Thank you, Eric, for those demos. Sorry for speeding that along. We wanted to make sure that we have also time for some Q&A at the end as well as the last bits. And yeah, with those demos, we only showed one journey. There's many, many more journeys possible. So that question about traces, if we could see it through system prompt, that is an option. Revert via deployment job, that is an option. We just wanted to make sure that we covered at least one journey so folks can at least get an idea of what you can do. But all those customizations you're thinking of, odds are, yes, you can probably do that. So now, going into basically, again, thank you, Eric, for kind of showing us what MLOps stacks looks like, especially today. Easy way to basically then manage and have basically very, very strict guardrails around your enterprise-grade architecture for MLOps. So if you want to do this now also for LLMOps, we're adding a new flavor for that actually called LLMOps stacks. Now, out of box, basically, we want to make sure that you can also have everything that you saw all streamlined. So that entire graph that we saw in the beginning that was very complicated looking, and rather than having to set all of that up manually, you can basically use MLOps stacks or LLMOps stacks, deploy the right bundles, and get all of that right off the bat. And that's really nice because having that template, it just makes it very easy to even refer to if you want to do your own thing or customize it. You can start from there and go from there. Whereas otherwise, like I said, you'd have to set all this up kind of out of the box. We try to make that easier with deployment jobs and everything, but naturally, yeah, you'll still have to go and create a model. You'll have to go create an experiment. You'll have to go and create, like your job. Having all of that in code as a source of truth as a DAB makes this very easy. So with that, with LLMOps stacks, what you get is all those things we talked about with the MLflow 3, all those benefits, as well as being basically able to use Unity Catalog for registration, for the governance for tools. You have basically CI/CD versioning and making it very easy to basically use serverless as well. So what are the actual components that we're now introducing? So you have all the components that you normally have in MLOps stacks, but we're also going to make it very free to ingest and prepare your data in these certain notebooks. We also set up a vector search index for you, so you can have basically that vectorized version of your data. Agent tool calling, we show an example. We have a template. We register one example of a tool for you. You can change that, whatever tools you may actually need, as well as then performing automated evaluation with LLM as a judge, and then having deployment management with Databricks model serving. So custom, foundation, external, agent, whatever endpoints you want to use with AI Gateway, all of that is available with model serving. And all you have to do is then basically switch out the model if you want to use a different one. Also, we use Databricks apps to then automatically deploy basically that app to a front end so that now you can basically have that entire thing from code all the way to deploying a nice app that you can share with customers all right out of the box. So you can initialize that and get started with it right away. as well as having some testing and CI/CD to make sure the entire thing is governed fairly well. Okay, so with that, now we can finally move into the Q&A section. But before I do that, because I imagine this will take up the rest of the time, I'm going to go through actually the ending slides real quick. We have some other basically product-led sessions for AI at DICE. This is the one we just had today. There's a few more that you can kind of see. I can see some folks running out right now to either grab these or lunch, reasonable, and tomorrow as well. So we'll be actually doing basically a deeper dive into MLflow 3 tomorrow and seeing a lot more features on that. So you can come check that out, as well as some of these other talks. Here's a QR code to basically try out MLflow 3. Yeah, you can basically get started. You can scan that. Wait a second for folks to basically scan that. Actually, you know what? I can just leave that slide up, and that's fine. And yeah, one quick reminder, please take your surveys at the end. We do check them. It does help inform what kind of content we should be doing. More demos, less demos, more yapping, less yapping. Let us know. We can improve the talk based on that. And with that, we can now close it out and do Q&A. So thanks, everyone, for coming.